Pat Israel, this is awesome. Thank you so much for having me. My name is Daniel Bohannon. Today I'm going to be talking about PowerShell obfuscation techniques. Just a quick blurb about me. This is normally what I look like on the internet. This is what happens when you don't shave for a while. So this is my Twitter handle, personal blog. Basically, I'm a blue teamer, I currently, for the past year and a half, have been an incident response consultant with Mandiant, based out of Washington, D.C. And for the 5 years prior to that, I did operational security for a national restaurant franchise in the U.S. There's a lot of content here. I want to be moving extremely quickly. All the slides will be online, so please don't hold it against me, but I want to make sure I cover all of the necessary components to make sure that the full impact of this talk is conveyed to help everyone in this room. So a brief outline. First, my motivation. Why did I start doing this research? What does it look like to actually prepare one's environment? Most of the clients we go and investigate don't have their environment set up properly to really be able to see PowerShell activity at the level you need to see it at. We'll then look at a very basic, kind of the most common, what we call remote download cradle, the PowerShell syntax to, in memory, remotely download and run in-memory content that we see attackers and pen testers alike using all the time. We'll then look at more ways to remotely download code. After that, we will look at some more obfuscation techniques. We'll look at some more encoding, decoding techniques, check out a couple new ones, and then we'll look at what I like to call launch techniques. And after all of that, if everyone is still on board, we're going to do a quick demo of Invoke Obfuscation version 1.6, which I just pushed to GitHub about an hour ago. That contains a lot of new features that I hope you enjoy. So with that, my motivation. As an incident response consultant, I really hadn't played with PowerShell from an offensive perspective much at all. I'd used it in operational security at my last job. So when I started to see attackers using PowerShell quite a bit, I started to look at, okay, what techniques do we have to detect PowerShell usage? And attackers love PowerShell because it's native on Windows 7 and later. It's enabled, and you can do a lot of really great stuff, primarily in memory. And if you don't really have at least command line logging set up, then there's really not too much you can do to detect this activity, especially if it happened some time in the past, typically what we're looking at when we do investigations where there's not an active attacker. We see PowerShell being used at every part of the attack lifecycle. And at the end of the day, a lot of people assume, well, if we monitor PowerShell.exe and look at its arguments, then we can detect any of this stuff, right? I'm going to ask a lot of questions that I'm going to make it sound like it's good, and it's totally not. And by the end, hopefully, you'll see exactly why. So what a lot of people do is they'll monitor mainly these two things. And these are the two most common things we see attackers using. They'll usually run encoded commands, which is basically just your base64 encoded payload. And they'll also use, again, this basic remote download cradle to download content remotely, run it in memory. However, for each of these, it's not the only way to write this syntax, and it's also not the only way to perform this function. And we're going to dive really in-depth into these examples here. So for me, as I looked at this, I said, okay, well, here's what attackers are using, and here's what our detection is doing, and it's catching that stuff. But what are ways I can perform the same functionality and get around our current detection? And I started to play with the syntax, and I got around our detection. Then I updated our detection. Updated the syntax, detection, back and forth. And this has been my life for the past year and a half. And it's never ending. So my goal for this talk, for the blue team, who in here is more blue team focused? Awesome. I happen to like the blue team. So my goal for you guys is basically to come away with an understanding of what's possible and the bounds of PowerShell as a flexible language, and have an understanding of the best way to look at detecting these kinds of attacks, and to be aware of what's possible. For the red team, I hope you find this helpful as you're doing pen testing to basically get around your organization or your client's detection, so you can help them become aware of how flexible this is and how they can think differently about looking for malicious usage of PowerShell. And then also just to basically demonstrate the tool that I built based on this research to make the generation of this code easy for red team and blue team to be able to easily test this stuff without having to spend hours trying to make sure you have everything escaped correctly, because I can attest that's not that much fun. So preparing your environment for investigating PowerShell. This is way easier said than done. And I have a single slide on here which is hilarious. But basically, at the very minimum, you want at least command line argument logging. So you can enable that in your 4688 in security logs. Sysmon EID1 is also, thanks Mark for that. Sysmon keeps getting better and better every day. Or you can do something like uproot IDS for real-time WMI-based command line argument logging, or any other tool that you have that does that. And then this last resource right here is from a colleague of mine, Matt Dunwoody, who put together this blog post, basically outlining the different versions of PowerShell and the kind of logging that you get with subsequent versions and why that really matters. And even walks through a good real-life example of what you get with each subsequent level of logging. So let's start with the fun part, the remote download cradle. Let's walk through an example of obfuscating this. Again, we see this being used everywhere. It's in a lot of big-name frameworks out there. It's copied and pasted around quite a bit. And basically we see we have invoke expression, which is going to invoke the string that comes back from this remote location. New object, net.web client, download string. This is a totally legit bit.ly link. You can run it. It's good, I promise. So, red team, attacker command on the top. Now, blue team on the bottom, how can we detect this? If we see this on the command line, what components would be good to look for? Well, we could say if we see invoke expression, and we see new object, system.net.web client, and we also see download string HTTP, this would catch this exact command, right? Do we all agree? All right, it would catch that. So, let's start obfuscating. First off, pretty much whenever you see system dot, you don't even have to specify system dot. Most people don't, but some people do. It'll automatically prepin that. So we're going to remove that from the attacker function and from our blue team code right here. All right, HTTP. So the URL here is actually a string. So there's a lot of ways that you can basically mess with a string. You could, say, concatenate it in line like that. So you can't really rely on HTTP even showing up there. So let's just go ahead and remove that HTTP. In addition, you can use single quotes, double quotes, white space. You could set it as a variable. So let's just make sure you remove the quotes on that string right there. Let's keep going. Download string. Mostly we see attackers using download string, but download string is actually a method of .NET, of the net.web client class. And it's actually a lot of options. Download string, string async, string task async. You have download file for something to hit disk. You also have download data, which gets a byte stream. You don't have to convert before you invoke it. But we've seen attackers use all of these. So there's a lot of options to be aware of. So why don't we just say .download and get rid of string, and we'll cover all these options, right? Everyone tracking so far? All right, let's do that. So we're still detecting this command, right? This parenthesis, you can actually set new object net.web client as a variable and then call it the variable name dot method. So just like this right here. And so in which case you just have dot download string without that parenthesis. So we'll go ahead and remove that. Now, download string is a member of the net.web client class. So how can we obfuscate a member? Well, because I'm really OCD and like to just kind of poke at things and see how can I break this detection here. The dot can actually be problematic if you have that in your detection, because what I found you can do is you can put single quotes around the member and it still functions fine. And then I found you can also put double quotes, and there's this amazing. This example is what got me hooked when I found this next thing. I want you to look at download string, and I promise this next slide works. Tick mark. Code executes perfectly fine. That breaks our detection. Now, why does this work? Well, tick mark is an escape character for PowerShell. Usually it's to do, tick 0 to be null, or tick B, tick N for new line, stuff like that. And actually, just last night, I was looking at the about escape characters on the Microsoft.com. It says, in Windows PowerShell, the escape character is the backtick, also called the grave accent. And I think they mean it's the grave for any good indicators we thought we had as defenders. So the tick ruins a lot of stuff. And what we can do is throw ticks in all the characters that are not preceding a special character, like N, T, things like that. But what you can actually do is for those special characters, if you just uppercase them, then you can totally put ticks in front of it as well. So for any member, we can put tick marks anywhere we want, and it totally ruins this indicator. So how do we cope with that? Now this is the startling part. These ticks show up on the command line for the live process, command line arguments, on your security log, sysmon, it doesn't matter. But the crazy part is that all the obfuscation we've done so far actually persist all the way to PowerShell script block logging. Now, script block logs are absolutely fascinating. Basically, if you have an encrypted command that's then encoded and wrapped in as many layers as you want, every single layer is basically displayed in its own script block log. And you see this massive command being unwrapped until you get down to the final command. That works whenever you're passing a command into an invocation function, like invoke expression. So whatever payload we're pushing into invoke expression, it will show the results of that. But this final command that we're running these obfuscation techniques are not being invoked by anything. So they actually persist in the script block logs. So any kind of AV or signatures that are using things like AMSI to look at script block logs, which is the anti-malware scanning interface, really awesome feature. You need to take this into account because this is what it looks like in script block logs. So we could try to regex all the possibilities here, but there's really a lot more ways you can obfuscate it beyond just saying removing tick marks or removing special characters. There's weird ways you can start to reorder strings. Basically, if you can get a component down to a string, you can mess with it beyond all recognition and make writing a signature for that exact string very difficult. And it's probably a good thing we removed this download because actually there's a fourth kind of subcategory of class here for net.web client that is open read, which is also a byte stream. And I've seen an attacker use that once before. So if you do try to go through the download route, make sure you also include that open read as well because it works and it's been used out there. Here's an example of us looking at the member and treating it as a string. You can basically treat it as a string, concatenate it, set it as variables, whatever you want. In PowerShell 2, you need to add that .invoke afterwards. PowerShell 3 or later, totally don't have to. So there's a few nuances between different versions of PowerShell. All the obfuscation that I've put into my tool is compatible with everything. If it's not compatible with 2, 3, 4, 5, then I don't put it in the tool. So let's just, are you okay if we remove that from our detection here? All right, let's keep going. Net.web client. This one's trivial. We can basically put it in double quotes and use tick marks. We can concatenate it if we encapsulate it with parentheses, or we can set it as variables just like that. So we'll just go with the tick mark option. Keep going. So new object. Now, when I got to this one, at this point, I was left with invoke expression and new object, right? So I said, well, I know PowerShell has a lot of aliases. Like if you want to say, list all the files in this directory, you can do the formal get child item, or you can do the shortened GCI, or you can use older commands like dir or ls, and it all translates because those are aliases for the commandlet get child item. New object has 0 aliases. So it should be pretty straightforward, right? Well, this got me thinking. I was playing around one day with get command. PowerShell, so many commands. Sometimes you forget the exact syntax. Maybe you're in a situation where you say, okay, I know there's a command called new-p something. So you can just run get command new-p wildcard, and it will show you all the commandlets or functions or whatever else. Now, the thing about PowerShell is that it's not returning text. It's returning PowerShell objects, which means if you return not a lot, but a single object, you can then invoke that object, and it runs as that object. So we can use invoke expression, but that's not the only way. We can actually use these invocation operators, an ampersand or a freaking dot. That invokes that command. Now, here's where it gets interesting. Remember the wildcards? What if instead of get command new object, we just did that? Or maybe kept going. As long as we return a single object, that's a new object. So now, if you're looking for a new object on the command line for tick marks, for string concatenation, you'll never see it because wildcard w-o wildcard is a new object. And get command, it doesn't stop there. Get command has an alias of GCM and also has an unofficial alias of command. Now, this baffled me. Why does command work? I couldn't find it anywhere in documentation. Well, PowerShell is very helpful, and if you type in something, it'll automatically just like prepend to get to it and say, hey, is this a commandlet? And if it is, it works. So anytime you're writing signatures on get, like get child item totally works by itself. So when you're writing triggers or signatures, if it has a get, then you can totally get rid of that get, and it will still work. Something to keep in mind. So instead of wildcards, you could also do string concatenation setting as variables. The sky is the limit. In addition, PowerShell 1.0 actually has some really good gems in there. This execution context. If you're not looking for execution context, hopefully by the end of this talk, you'll be looking for this variable. But unfortunately, there's 1,000 ways to call the value of a variable, so a lot of times it never looks like $ execution context. But it's something to start looking for. You can use get command, get commandlet. You can use get commands, get commandlets, or a combination of get command and get command name to basically use wildcards or not use wildcards. This is all still working to run new object. And finally, just like with get command, we can use get alias, gal, or alias, and you can do wildcards, but at that point you're dealing with a shortened alias name, not the full command. So new object has no alias, so it doesn't help here, but for other things like invoke expression, it has the alias of IEX. You could use get command or get alias for that stuff. So we'll go ahead and add that to the list. The 1.0 syntax is way too long to add to that list, but hopefully you can see this is getting really complicated if we're trying to look at all the known ways to do this, right? So we'll just go with that option right there, get command w-o. We'll use the ampersand invoke operator. That's new object. Let's just go ahead and remove that from the indicator list, if that's all right. You could also just throw tick marks in front of it if you want. So the options keep stacking up. You can also do this amazing thing called splatting, which you can basically just use the invocation operator and just piece together your command in a string, and that gives you even more options. Remember, once you get to a string, you can completely twist that string up and make it appear in all weird places in the command. So let's get rid of that indicator, and we're left with invoke expression, which is actually a fantastic place to look for. If you see IEX or invoke expression on the command line, if you're not monitoring for that, it's something you want to start monitoring for, because it catches a great majority of the stuff that we see attackers using. But how can we get around that? If we're a savvy attacker, what things can we do to mess with detections that are looking for this? Well, there's a lot of opportunities here. First off, invoke expression has an alias of IEX. Let's be aware of that. Ordering doesn't matter. You can actually have invoke expression at the beginning or have the contents piped into invoke expression. We have tick marks we can add to any commandlet. Remember that? We have splatting. The bottom is an example of using the F format operator, which is my new best friend in obfuscation, where you can basically piece together substring and random order and then reassemble it based on the index of that string. So index 1 and index 0 basically swaps those around. That's IEX right there. This is something I tweeted just a couple weeks ago, basically where can you find in environment variables or PowerShell variables the letters I, E, and X and piece them together? So this shell ID is a variable that says like Microsoft PowerShell, something like that. And the index 1 and 13 is the letters I and the letters E. We just throw in an X in there and then invoke it, and that's IEX. So in the version of invoke obfuscation I just pushed today, I basically created a lot of additional functionality in the invocation operator. So whenever the tool adds an invocation operator, it will choose a random list of a lot of these crazy environment variables and PowerShell variable strings, just to show that IEX and invoke expression are good, but you totally can't rely on ever seeing it look like that. Even with tick marks, even with the F format operator, you can still do weird stuff like this. Then we also have invoke expression's cousin, invoke command. Now, most people think of invoke command as running a command on a remote system. That's typically what it's used for, but if you don't specify a remote system, it runs locally. So really the biggest difference at that point is invoke expression is expecting an expression or a string, and invoke command is expecting a script block. So invoke command, we have an alias of ICM. You can also put a dot invoke after the script block, as in the middle example, or we can use the ampersand and dot invoke operators. Now, typically, you'll see a script block that's denoted by these curly braces, right? So this got me thinking, okay, let's add all these to the list. Now, how do I really key off of a dot or an ampersand? Like, that feels a little false positive prone to me, and it definitely is. So what if for those I said, okay, I only want to alert if they have curly braces? That's going to be a problem. We'll see why in a second. Also on this list, we have PowerShell 1.0 syntax. There's the execution context again. Invoke command, invoke script. It actually handles either an expression or a script block. Doesn't even matter. It handles them both. So we can add ticks to all that. We can do any of the splatting, all the stuff we've looked at. So again, let's come back to this example with a dot or ampersand invoke operators. What if we say I only care about those if I also see open and close curly braces because it's a script block? What's the problem with that? The problem is you can convert strings to script blocks. And there's two basic ways to do it. One is you can use the .NET script block create, or you can use, once again, execution context to basically cast an expression to a script block, such that we can use the dot or ampersand invocation operators on an expression where curly braces are never present. So this basically means I do want to see whenever there's a dot or an ampersand, which means that life is really not easy at this point if I want to look at all these invocation possibilities. For each of these, you can obfuscate, just like we've been doing, all the elements of this command. This is the .NET command. This is the PowerShell command. You can go through, add ticks, do all that kind of stuff. But what I realized at the end of this was, for both of these, you still have your full command as a string in this expression field. And remember, if you can get a thing to a string, you're good. Because now we can basically, after all this token level obfuscation of ways you can obfuscate the member, the commandlet, the string, all these kinds of things, you can basically take everything you've obfuscated and then say, all right, let me treat this whole thing as a string, and now I can step back to layer 2 and say, what are all the string manipulation functions we can do to this? And then I just have to pass it into an invocation function. Now, script block logging will detect each layer of this. But again, with all the token layer obfuscation, that persists all the way to script block logs. So depending on what you're trying to evade, then using a different set of obfuscation techniques can be more helpful than others, or you can totally just throw them all together and then be pretty okay. So this is our crazy regex. Maybe if we wanted to try to do that, I don't want to do that. So nothing really solid unless we're up for regex torture. So that's the final command of what we chose to do, and that totally works, and that's terrifying as a defender. But there's weird, like, that, when you look at this as a human, that's not normal, right? Like, how many tick marks would you really expect to see? And this is where I propose the shift from not only looking for known bad PowerShell syntax, because it's so flexible. You can do so much with PowerShell, with .NET, with like loading C# and all these other things, that enumerating all the syntax possibilities like I've been doing with this, I think it's good. It's good to be aware of, but we shouldn't place all of our eggs in that one basket. We should also say, in addition to looking for known bad, why don't we also look for indicators of obfuscation? How many tick marks is too many tick marks in a command in my environment? How many curly braces, $signs? We'll look a little more at this, but start to think about these things. As you see these commands, your human instinct says that is not right. How do you translate that to a computer? And machine learning, I think, has a big role to play in this. So that was just looking at the most basic download Cradle. What other options are out there? Well, this is the basic one we looked at. If you have PowerShell 3 or later, you have invoke web request, IWR. You also have invoke REST method, IRM. Or you can just call the .NET classes straight up. And again, system dot, not necessarily. You can just remove those right out. So we have a lot of options here. These are just a few of them. So what about if you are trying to get into a target system, and let's say they're looking at processes that make network connections. And maybe they're using Sysmon EID3, and they say, whenever PowerShell makes a network connection, I want to know about it. Well, then they're gonna see our stuff, right? So what if we, I don't know, opened up Notepad, and instead of putting in a file, we put in a URL, and then hit open that file. Notepad totally just goes and gets that. So this got me thinking, how can I automate this? Well, there's this great little class called SendKeys that you can have a lot of fun with. This example, PowerShell uses SendKeys. The COM object to say, spawn Notepad, and then let me enter the keys, Control-O to open, types in the URL, Control-A to select all, Control-C to copy all, and this last part of the command will basically rip the contents out of the clipboard and execute it, and PowerShell never made a network connection. Is that not crazy? Now, this is a kind of funny sample process, so thank you. Hopefully this would cause the user to be suspicious, right? But there's nothing stopping you from minimizing that when you do this, right? So this is just a really crude example. Another thing to call out is that if you have SendKeys, you see the little tilde? That's just one of the ways you can hit the enter button. But when you hit enter, if you're in an interactive session, you don't have to technically do invoke anything because your enter is the invoke. So even if we're looking for all the invocation functions, if you use SendKeys and enter, that's an invoke right there. Something else to keep in mind. And basically anything that we do with PowerShell is making it easier for us, and it's typically giving a defender more visibility into what you're doing. So the top portion is PowerShell SendKeys example. The bottom portion is .NET. And within .NET, if you can basically add this void in front of it, you're silent in the logs. So whenever you're looking at things you can do in PowerShell, if you can go into .NET and do it there, typically it's going to be quieter. As a defender, am I saying this to be mean to us? No, I'm saying it because attackers are doing this, and we need to be aware of all these syntaxes. And if we see void on the command line, or how many square brackets, how many .NET classes do we typically see on the command line? These are things we need to start looking at. Basically, any GUI application with open file functionality can do this. PowerShell ISE is fun because after you get the code, you can just send an F5 key and it automatically runs it for you. You don't have to do a clipboard or anything like that. This actually does hit temporary internet files when you do this. Sometimes it maintains the name, sometimes it doesn't. Here's just a quick little blurb on that. Excel actually changes it to a random name. But there's other indicators like recently opened files in Word or Excel. If you do this method, you'll actually start to see those links pop up to the user. So not the cleanest method, but there's a lot of other forensic artifacts you can look for as a defender that may help you out if you suspect this is being used. So again, SendKeys, kind of funny, a little sloppy. There's actually some really cool things you can do with COM object interactions. So what if, like in this example, we just said PowerShell, why don't you create a COM object of iExplorer? And PowerShell doesn't even spawn iExplorer. The existing SVC host spawns iExplorer. Internet Explorer goes, fetches my payload, brings it back, and PowerShell says, yeah, I'll have that, and grabs it and invoke it. So this is a much cleaner method, in my opinion. There's a lot to be explored with COM objects. Casey Smith and others are doing some really great work on that. Definitely recommend following them. I always learn stuff about that, but COM objects terrify me from a defensive perspective because it's very difficult to tie it back to the process that's invoking it, whether it's PowerShell, a macro, other things like that. But it uses, I mean, Internet Explorer browsing the internet is like pretty normal MO, right? So it looks a lot less suspicious than PowerShell doing that. So just keep in mind, looking for PowerShell making network connections, not the only way for PowerShell to execute remotely downloaded code. More obfuscation. Let's keep going. So remember I said if you can get something to a string, you're golden. So let's look at the string level obfuscation techniques. I'm going to go really fast to do this. So basically, you can like reverse strings. So if you're looking for IEX, then now it's XEI. You can reverse it through .NET functions, through regex, through iterating as an array in reverse. A lot of different options there. You can also split string. You can put garbage delimiters in your command, and then split on that delimiter, and then rejoin the command. And on the command line, it's all chopped up with these delimiters. You can do the same thing with replace. Again, put in garbage delimiters, replace it with nothing. You're good to go. You can also do concatenation through so many different ways, it's not even worth trying to put them on this one slide. All to show a basic command can be chopped up into a lot of little pieces and appear on the command line, not at all like you'd expect to see it. So, again, what do we do with this information as defenders? Well, we need to start looking for this stuff. How often do we expect to see on command line, reverse, split, join? There are some applications that do it more than others, but if you're doing security for a single environment, you own that environment, and it's a little bit easier to start to weed out those false positives. For us, when we have to make something work for all of our clients at the same time, it becomes a lot more difficult, and it takes a lot more effort to come up with how many times should we see this, or if we see this in combination with these other characters, then it's more suspicious or not. Looking for high counts of certain characters, let's say $signs, for how many variables do you expect to be set on the command line, or how many semicolons should there be on the command line for a number of little commands if you're trying to chop up, string concatenations. But as you see in the red, there's alternate ways to do this. Set variable, get variable. You can create and interact with the variables without a single $sign ever being shown. You can do multiple commands by piping anything into for each, and then adding each command in a script block. And you can do concatenation without any pluses. Always alternate ways to do this. And one fun example of that is if there's any character that defenders are keying off of, just do a char conversion. We have 4 commands here, C1 through C4, and we're basically going to put in 2 tildes as a delimiter, and then we're going to split or replace that delimiter with string char 59, which is a semicolon. So any character that's problematic, just do a char conversion. And there's tons of conversions you can do as a defender. Do we care if char conversions are happening on the command line? That's not a normal thing, but it's not the only way to convert stuff. So when you start thinking in terms of how many different ways can we represent this one thing? Speaking on the lines of char conversions, there's differences in how you can obfuscate types between 2 and 3, PowerShell versions 2 and 3. Here's a quick blurb up here. I'm going to keep going, but there's ways that you can really mess with even square bracket char to make it look quite different. The easiest of that is direct typecasting, which is what's included in invoke obfuscation. All right, what's old is new, encoding, decoding. So this is all fun stuff. Hopefully you find it interesting. This is mostly stuff that has just kind of been like me being OCD in a lab and looking at all this stuff and reading a lot of TechNet articles and looking at blogs and forums and that kind of thing. What are attackers actually using up until this point? Well, they've been using what works, and that is encoded command. Because PowerShell gives it to you. It takes care of all these crazy tick marks and escaping. It gives you a nice base 64 encoded blob. All right? That's what attackers are pretty much using most of the time. It's easy to copy and paste. You also will see these execution arguments not non-null for no profile, non-interactive, no logo, different things like that. If you've done detection on PowerShell, this should look very familiar to you. And a lot of tools will generate the exact same ordering of these arguments and stuff like that. The more I started to look at this, though, I started to see a little bit of variation. Like for window hidden, some people will just use W. Some people will put window, and they all worked. And I could never find good documentation on the full list of all this stuff, and it really frustrated me. There's other ways you can change these things in registry or other locations. But encoded command, this is a really good one to key off of. And these are the 5 samples that I saw. And I couldn't never figure out, I was like, all right, encoded command makes sense, EC. I saw documentation for those 2, but never for anything else. So if we had this as our detection for these, would this catch all instances of encoded command? Space, dash, encoded command, space. It would catch these, but here's what's problematic about that. PowerShell gives us EC and encoded command, but then they also give us that. And they keep going. They give us all of this because we need our options, baby. Now, why does this work? PowerShell auto appends a wildcard to flags. Any function you're using, any commandlet, as short as you want to get that flag, as long as it returns a single object or matches a single argument, it works. So that's why you have not, nani, and null, because that's as short as you can get that string where it returns just that argument. So for no profile, you could use nop, N-O-P-R, N-O-P-R-O, N-O-P-R-O. So anytime you're keying off of arguments, even like for invoke mimikatz, dump creds, dump certs, you technically only have to say dump CR or dump CE and any substring in between. This is why in invoke obfuscation, when you're basically applying launchers and want to launch PowerShell code from PowerShell, when you select all these arguments, it will basically go through and randomly select the full string, any like shortened string like EC, and then it will also generate every single possible substring and randomly choose every single time which one it's going to use. In addition, it will randomize the order of all these arguments. There's only one or two that order matters to be last or first, but it'll randomize the order of these arguments and also randomize the white space between the arguments. Because these are all things that I've seen people use as detections, and it's okay, but it's stupid easy to break. So I just wanted to break that habit with this stuff is possible, it works, why not automate it and help people realize this is not the best way to key off of this stuff. I need to be aware of what's possible. Attackers also use .NET ways to do base64 encoding or compression, that sort of thing. What about some different ways? What about ASCII or hex or octal or binary? These are all possible, and I've not yet seen attackers do this, but since it's possible, I put it in the tool because we should be aware of it. We should be looking for syntaxes, and this is definitely not a complete list, but syntaxes to do these kinds of conversions because it still helps you just like encoded command. It gets around weird, escaping and all this kind of stuff, but a lot of people aren't looking for it. So this got me down a really weird trail one day. I was looking at passwords in PowerShell. PowerShell 1.0 has this great thing called secure string. Really, it's .NET. But secure string objects are what you're supposed to store passwords in. So I was looking at this one day, and oh, that's not right. Hold on. As secure string, but you know the whole wildcard thing. Actually, same flag there. So if you're reading a password as a secure string, then you can convert it to a secure string. And then what you can do is you can convert it from a secure string and get this big blob of data right here. And if you don't define a key, then it uses DP API and uses the username, computer name of the system. And it will always start with this highlighted substring right there. However, if you use a key, then you can generate it on one system and then run it on another system as an encoding mechanism, and then it uses AES 16, 24, or 32-bit encryption depending on the size of the key you pass in. Now, the size for this, for your secure string password, is 65,000 characters. I feel pretty good about my passwords, but I've never felt 65,000 characters good. Like, why is it so large? And this is what really stumped me. And so I got to think, well, either someone has a crazy password, or maybe we could like shove an entire script into a password object and use it as an encoding, decoding mechanism, and that's totally what I did. So we're not using this for passwords, just as an encoding, decoding, which is technically encrypting, decrypting. And basically when we do that, this is one of the ways that we can invoke it on the target system. In the code release I pushed today, I actually introduced a couple more ways using different .NET classes to do secure string. So if you have looked at those options and built detections around it, definitely check that function out. There's some more fun in there that we need to be aware of. After I did this POC, I was looking on TechNet for something totally unrelated, and I saw back in 2010 someone posed this question: is there any obfuscator for PowerShell? And this guy came back and said, I guess you could put something together using secure strings, and basically described exactly what I did. And I was so bummed. I'm a boss. I said, hey, I sent him the link, and I said, like, I thought it was something original I came up with. This person totally had the idea. Like, I feel like they deserve credit. And about 2 seconds later, my boss replied back and said, dude, 0 upvotes. You're good, man. Ends up the guy's a rock star on TechNet, so kudos to Just Carl for coming up with this idea. But totally possible using something meant for passwords as an encoding, decoding mechanism. Finally, launch techniques. We've covered a lot of ground looking at token layer obfuscation, string layer obfuscation, all the different syntax ways that you can do remote download commands and encoding techniques. So how do we actually launch this? Most people will look for, command launching PowerShell. There's a lot of binaries that can be launched from PowerShell, but ultimately, this is to break the concept of only looking for PowerShell.exe and its arguments. So what's problematic with that? 2 problems. One, I'm totally not going to cover. Unmanaged PowerShell is an entirely different problem to deal with, and that is PowerShell.exe is not PowerShell. System management automation.dll is the underlying guts of PowerShell, and you can call that through a lot of different means, C# applications, and the world is your limit. So just looking for PowerShell.exe is not the only way to catch PowerShell code. That's why PowerShell 5, which just has incredible logging, is definitely something you want to get to as fast as possible if you don't have it, and looking at those logs, because it will capture the PowerShell commandlets being run, the script blocks being run, whether PowerShell.exe called that, or some completely different binary that's injecting that code in using this unmanaged PowerShell concept. I'm not talking about unmanaged PowerShell at all. I'm still strictly looking at convoluted ways to launch PowerShell.exe such that it might break detection mechanisms that you have in place, because it definitely broke all of ours when we first came across this. So if you do PowerShell help, you'll notice that you can specify a command. We use dash command. And then it also has this nice little feature of you can just end the command with dash, and it receives the command through standard input. So when we do that, in the second example here, if we have command and we echo the command and pipe it into PowerShell tick, it works. But when we look at, you can, instead of the dash, you can also use the input variable. It does the same thing. But when you look at the PowerShell process, the argument is just PowerShell tick or PowerShell input. Parent process has all the details. So maybe we should start looking at PowerShell and its parent process. We're good, right? No, not really. There are other ways that you can do this, right? So you can basically set environment variables and then call the environment variables. Cofter malware does this quite a bit. There's also a lot of ways that you can call an environment variable. $env is just the tip of the iceberg. You can use get child item, get variable. Actually, this last one I just added, I found this past week, get item, GI item variable as well. A lot of options there. We could also use the clipboard example, just like we did. Parent process set something, pipes into clip, and then spawns PowerShell to execute what's in the clip. This is not good for us, right? So if we only look at PowerShell and its parent process, there's nothing really stopping us from going further, right? So what if we do this? What if we add a third process? We have command number 1, setting the script, and then spawns command 2 to echo that variable into PowerShell. PowerShell is the third process that invokes it. Well, when we do this, it technically works, but the parent process still shows the full command line arguments, unless we do a little bit of escaping fun. So this pipe, we need to escape it one layer. We need to escape it for the first command, so it only is working for the second command. And when we do that, we're good. PowerShell, no command details. Parent process, no command details. It's in the grandparent process. There's nothing stopping you from going further. In my tool, I stopped at this level. I figured it was enough to prove the point, but basically, even recursively looking up isn't the best way to look at this, because what you can do is you can set it in different variables and query out that information. Clipboard is one example. If you have your starting process, spawn a process to echo into the clipboard, spawn another process to read the contents from the clipboard. If you see PowerShell running with that clipboard syntax and you recursively go up, you'll never find the actual command. Now, the craziest thing I've ever seen is an attacker that did something very similar to this, where they used WMI to spray multiple processes, spawn multiple processes with pieces of the command, and then it spawned a final one to use WMI to query the command line arguments, repiece them together, join them, and then invoke it. That's crazy. Demo time. All right. Please don't use this tool for evil. Use it responsibly. If you're using it for red team stuff, please have permission wherever you use it. Don't get me in trouble for that. So just run PowerShell. In the update I pushed today, I actually converted the invoke obfuscation.psm1 to a psd1. That's, I was told, more correct. So just do that import module, and we run the function. I'm a big fan of ASCII art, animated in particular, so this is stuff that my wife can appreciate. The code doesn't really, it doesn't really do anything for, but the colors are nice. So you have this nice help menu here, and basically anything in yellow will take you to another menu. And green will actually apply obfuscation. So we'll just do, we'll look at the tutorial here in a second, but these are our main categories: token, string, encoding, and launcher obfuscation, kind of the order we progress through in the talk. So tutorial, it'll show you, you can do set script block and then define your script block, or you can do set path and define a remote URL, local file, doesn't matter. So we set that command, and in the tutorial it says if we go to encoding and then number 5, it'll apply secure string obfuscation. So we type encoding, we type 5, it applies randomly selected secure string obfuscation. As much as possible in this tool, everything is randomized. We can run show to give us details. Here's our original command. Here's each layer of obfuscation we applied. Here's the obfuscated command, and here's the length, which is important if you want to fit it onto the 8,191 character command line limit, depending on how you want to launch it. So let's do a little more fun example. We're going to set script block for this animated command here. So let's look at our token layer obfuscation. string, command, argument, member, basically every tokenized element in a PowerShell command we have here. So if we go into string and then apply that, you can see every string in the command or script is obfuscated. Let's go to command. We have more options here. Ticks, splatting with concatenation, splatting with reordering. So now every commandlet is splatted, and it's treated as a string that's reordered with a -F format operator. And there's CLI for the win. That's the message that we put there. So it's kind of cumbersome to go through every single item here, so you can just go to all one, and it'll go through and randomly do that. You can run it as many times as you want, and for all these obfuscation techniques, stack them any order you want, as many times as you want. You'll see that command get nastier and nastier and nastier. So let's go back to the home menu. Let's look at string. So we have straight up concatenate, we have reorder, we have string reversing, and again, you can stack all these together as many times as you want. It gets pretty big, pretty nasty, pretty fast. Anytime you just do reset, remove all obfuscation. One of the things I added was the undo button. Surprisingly, it took me a lot of time to finally add that, where you can undo just a single layer of obfuscation. So if you've ever used the tool, then you've probably gotten as frustrated as I have about not being able to undo a single function. So we're looking at our encoding options here. Again, all the ones we talked about: ASCII, hex, octal, binary, secure string, and bitwise XOR. It'll choose every element of the command can randomize. It'll randomize that in the syntax. And as you can see, at any point, you can run test, execute, whatever, and it'll test just to make sure your command is still working. And again, you can stack all these one on top of the other. And if you ever hit that limit, it tells you, hey, you passed the limit. So you may want to run undo and not do that last thing, or maybe do it earlier, depending on what you're looking for and how you want to launch it. So there's our command. Now, a new feature is command line interface for this version today. So you'll notice this new field up here, command line syntax. This also includes being able to string together multiple commands and fully path the commands in interactive mode or CLI. So with this command, we ran encoding 1, encoding 2. We can also start with a reset and basically loop it and run it as many times as we want until we're satisfied with the command that's output. So we can add token all 1. Another thing, you don't have to go back to the home menu anymore. It'll auto-detect if you're specifying a home menu. So I've tried to make the interface a little more usable, a little easier. This is my VM totally just chugging through this encoding procedure right here. But this also makes testing a lot easier, so it's a lot easier to generate a lot of code as a defender to test your detections. And you can also use full-blown regex for any of these commands. So for any part of the command, you can do regex to randomly choose each time which of the options you want. So we'll basically do that. We'll basically say encoding, star, anything, I don't care. Let's do string encoding, either 1 or 3. And it'll basically tell you we randomly selected 1 through all the options that was available given the regex that you presented. And then the very last part is actually applying the launcher, if you choose to. If you want to run it straight in PowerShell, just run clip to copy to the clipboard, or out file name to get it out onto Notepad, and you can paste it into whatever tool you want, or you can go into your launchers. And so for this, we'll just do launcher star plus plus, which a single plus says this launcher is going to push the arguments up to the parent process. Plus plus means up to the grandparent process. So when you're looking at the launchers, that's what that means. And this is what it looks like to run it completely outside of the tool, pasting it into command. Very last thing I'll show is, again, going back to, or actually the process argument tree is one more thing I added to this. So for every launcher, for the defender, it'll show you each step of the chain. So you can see for this launcher, what does it buy me as a red teamer? But as a blue teamer, what do I have to work with? So it's really important to look for the syntax to do these weird kinds of things like standard input, clipboard, all these kinds of things. That's important to look for in PowerShell, but don't place all of your eggs in that one basket. And again, for the full command line syntax, we can just copy that out and paste that straight in outside of the tool, and it will run through all of that and output your code to standard out, pipe it to a file, or you can add the clip or out command to the command line interface, and you're good to go. That was a lot. That was a lot of content. Lastly, you can add a no exit if you want to basically automate all the obfuscation and then end in the interactive tool to do the last bit manually if you're so inclined. So those are a couple highlights for the updated version. Again, command line interface, multi-command regex, home menu syntax. I did remove white space from the automated token all because it took a long time for really large scripts, so you can go back and manually add that if you want. Basically, introducing random white space at every place in the command or script that it can. If you want to just enter in a script block as PowerShell encoded command and your encoded command blob, then it'll basically grab that blob, decode it, and set that as your script block to make it a little easier. Numerous weird invoke expression syntaxes, and of course, the undo command, the thing I'm most proud of. So what does this mean for the blue team? Well, at DerbyCon this year in Louisville, Kentucky, Jeffrey Snover, really the father of PowerShell, talked about the difference between real security versus hope fueled by ignorance. I hope in a sincere way that this shatters any hopes that we were doing a great job with detecting this stuff. And I don't mean that mean or sarcastically, but we need to be aware of what's possible, because that's the only way we're going to get better and challenge our assumptions about are our detections working or are there things getting through. So this is what I felt like many times as I'd come across another technique and realize, well, there goes the past month of all this detection stuff I was feeling confident in. How do I make it better? So at the end of the day, I'm talking about this and sharing this tool because obfuscation is already being used in the wild. Just ask this guy, John Lambert. He posts some awesome stuff on Twitter and seeing this crazy obfuscation stuff being used. Secondly, a purely command line driven approach to detecting obfuscated PowerShell is absolutely frustrating, and it's not ideal. If that is truly all you have to work with, you can kind of make do with it, but you need to be working to get those PowerShell logs as quickly as possible and being able to do something with them in a single place. So what about if attackers were using this in Python or something like that? Like, how good is Python's logging? I'm not just bashing on Python, but people give PowerShell a hard time. What other scripting languages has logs like PowerShell? Great logs. PowerShell has given us a gift on a golden platter with these logs. We need to make sure we're using them to our advantage. PowerShell script block log simplifies everything, all the obfuscation we talked about, except for the last layer of token layer obfuscation. Be aware of that. And finally, break all assumptions, know your options, and hunt not just for known bad, but also for indicators of obfuscation. Credit where credit is due. I get to work with a lot of really great people who encourage me in my research, and my wife mainly in putting up with me spending this much time on development and research. So a big shout out to all of them. And that is my talk. I'm at time. But I would love to take questions afterwards or talk to you all throughout the conference. Thank you very, very much for having me. This has been awesome.